Welcome back. Today we're going to build the basement stairs. As I mentioned on the last video, I decided to build the basement stairs before doing the subfloor sheathing, so that's what we're going to do today. But before we get too deep in, let's take a look at what we're going to be doing. So if you've been following along, this is about where we are at currently. You can see all of the subfloor joists, the carrying posts, the carrying beams, the walkouts, the windows here, and the stairwell opening that I've finished, and the stairwell pocket and the supporting walls for this stairwell opening. If I get rid of the subfloor, we can take a look at what we're going to be doing next, which is building the stairway. So I have, in fact, let's get rid of the stairway. I have most of the supporting walls of the stairway pocket built. I need to extend it into this wall and complete this wall as well for the border of the entire stairway. And then we can actually turn to the stairs themselves. Turn these off so that we can just look at the stairs. The measurements on the model are a little bit different than on site. The only difference is going to be that I'll have 3 steps here instead of 2, but this is basically what we're going to be building. So from top to bottom, we want a ledger board up here to catch the top of the stringer. We want a kickboard down here to catch the bottom of the stringer, and we'll do the same thing on the lower stair piece as well. And normally you don't want more than 6 feet of horizontal distance without a support on a stringer. So we have about 11 feet 9 inches of horizontal distance on this stairwell. So I'll be putting a support beam, support little pony wall right in the middle of it for support. And then those will get attached to the stairwell pocket as well to secure it and keep it from waving back and forth. But that's what we're going to be doing today. So let's get at it. A couple of things worth mentioning at the outset. So if you've been following along, you know that there is a little bit of an angle here in the corner because of a lack of perfect squareness within the foundation. And so this is where it's going to have an impact. So this wall is going to get closer and closer into this corner. In fact, I had to cut down the bottom plate, as you might be able to see here. And in fact, what I started doing as I'm getting closer to that wall is I'm turning the studs from perpendicular to the bottom plate to parallel with the bottom plate. The only purpose for the wall in this corner is to define the edge of the stairway pocket and to hang drywall on, so there are no support requirements for it. So turning studs in this fashion just gives me more space to work with. I have had some questions about the green foam board. So that's 2-inch high density foam. It's an R10. It lines the edge of the wall down past the slab all the way down to the footer. It acts as a thermal break. And any area of the basement that is below ground will get that foam board. I may put it all the way around, but quite frankly, it's just expensive. So for the areas that of the basement that are above ground, I may do some other moisture treatment and just use rock wool, which is what I'm planning to use in the walls of the rest of the house as well. I am still likely going to spray foam the roof, as I have had some experience with spray foam, and for insulation efficiency, as well as the fact that it pretty much glues the roof system together, it's a pretty bulletproof solution. But that's not what we're talking about today. So I'm going to finishing up this wall now, and we will move on to the landing, which is the first piece that you have to do when building the stairs. Of course, if this were a straight run, I wouldn't need a landing, but since it's going to turn 90 degrees, I need to calculate where that's going to be in relation to both the top and the bottom landing. The easiest way to do that is to really calculate the stairs as if there were no landing, as if it were a continuous run, because that will give you the steps, the number of steps that you need, and the amount of rise for each step. And then by doing that, all you need to do is calculate if you want the landing to be the 3rd step or the 4th step. You can just multiply the unit rise by the number of steps that you want to have on the bottom or the top to get you where you want to be for the landing position. After that, it's really just a simple floor build. I didn't have anything smaller than 2x12s on site. I probably didn't need 2x12s to do this. It's a pretty short span, but quite frankly, I like building any floor piece in the same manner that I'm building it everywhere else. It just ensures security and that it's all going to feel sort of the same. I will be layering this with the Advantech subfloor as well. And then once that's complete, I will be able to start the stringers and work on that part of the steps. As with any piece of subfloor, you always want to glue it down. In here, I'm just using construction adhesive, but on the stringers and the treads, I'm going to be using the gel foam with the applicator gun, which I've never used before. It's actually pretty nice. I'll talk about it more in a little bit. But this gives me my starting point for being able to determine the measurements of the stringers, and that's where we are now. So at this point, I've calculated the tread length and the riser height. Treads will be 11 and 3/16. The riser height will be 7 and 3/16, which puts me at about 18 and a half, or a little less. And that is right in the sweet spot of sort of the comfort level for stairs. That's something you need to think about. It's usually tread plus riser somewhere around 18 is what you're looking at. So you see I've got a notch out for the kickboard. I've numbered each of the steps. I've X'd out the areas that'll get knocked out because it can be, it's not confusing, but it's not a bad thing to do. There's the midpoint for the pony wall that I'll mark out there and cut as a part of this template. This first stringer will be the template for all of the other stringers, so I'll do the detail measurements on this, make sure it's really accurate, and then marry this up to the next stringer and just transfer the markings from the template to each stringer after that. As mentioned before, I don't have power on site yet, so I really am relying a lot on these battery-powered DeWalt tools. I have quite a few of them. I have to tell you, these stringers, because of the tension in them, really drained the battery power on this saw really quickly. I think I got through 1.5 stringers before the battery died, and it was a brand new battery. So I had to turn on my generator and get out the skill saw in order to complete the rest of the stringers. I've seen carpenters that will use just the skill saw and overcut so that they don't have to come back and do the notching. And they say that there's no structural integrity problems with that, but I just have a hard time believing it. So I like to go back with a jigsaw and undercut with a circular saw a little bit. Here I'm screwing down this stringer because there's a little bit of a twist to it and I want it to be flat. And then, as I often do, I'm going to use some clamps just to clamp it in place on the stringer itself. As I mentioned, these stringers have tension in them, as all wood does, and each piece of wood is going to have different tension. So what I'm really doing here is just drawing the template spine back to the spine of the new stringer so I can make sure that I'm always measuring exactly the same thing. The tension release will cause a lack of uniformity when they're sitting idle, but we'll take a look at that in a little bit. And the pony wall ultimately will address that by pulling it all into the same location. So now after I've cut the stringers, I'm going to just put them in there, test them. I'm checking level on every single step just to make sure that it feels right, and these are pretty good. Now I've got all 4 of them in here, and you can see immediately that they're not even close. Like if I tried to put this in like this, it would be a horrific staircase. So what I'm going to do is, one, double check that I did everything correctly and that I cut everything correctly. And the way I'm going to do that is I'm going to use a couple of boards and more clamps. And this is going to mimic what the pony wall will do. So this will just give me confidence that before I build the pony wall, before I put all the stringers in place, before I try to put down treads, that these stringers are in fact cut accurately and are going to work well. And so with these boards sandwiched in there, the stringers really came into place. And now you can see with that, the stringers look really good. They look really flat, and any like minor adjustments can be made once they're in place, but I'm pretty happy with that. So this stairwell pocket is 44 inches across, and you want to leave yourself an inch and a half on either side in order to allow for drywall to be slid down if we decide to do that all the way from the top to the bottom. And that's a half an inch, and then also for a 1 inch skirt board on the edge of the staircase. So that's why I have inch and a half on either side. So that's 3 inches. So that means the total width of the stairway is going to be 41 inches. And because of that, I really need 4 stringers. Some would say 3 is enough, but at the end of the day, it's $50 more for one more 2x12 16-footer in order to make the stringer, and it's just going to stiffen up the staircase, especially with the addition of the pony wall and the subfloor like 16-inch on center anyway, and even 3 of those would not quite make that, so that's why I've added the 4th stringer. Here I'm just adding a skirt board at the bottom so that I can have a ledger board. I could have used joist hangers here, but I just don't like that idea. I really like the idea of having a physical limitation like a ledger board, and so I just added a skirt board at the bottom to catch that ledger board so that I could do that. Now I'm adding the pressure treated kickboard. Remember, anything that touches concrete needs to be pressure treated, so that lower staircase is in fact all pressure treated, the stringers and the kickboard. Now I've cut all of the treads, and now I'm just checking width and checking level. I am using that applicator gun with the gel. It's really easy to use. It's very manageable. There's a lot of granularity in terms of how much comes out, and it's ultimately just going to be super strong. I also just like testing it before I do all of the subfloor sheathing because, like I said, I had never used it before, but I'm pretty impressed. We know the bottom of the stringers are at 41 inches because I put boards in place in multiple locations on the stringer, but because of the twists, it can be different at the top. And so I'm using clamps in order to bring the top to 41 inches exactly everywhere as well. One thing I forgot to mention is the pony wall that's supporting the stringers. In the model, I had 4 2x6s, spread across evenly. But what I decided to do is add a header board instead. You can see it in an earlier shot in the video. And what that allows for is just really good access under the stairs. So we can use this for storage, or I may be able to put in cabinets or something in the lower section here just for additional storage downstairs. So that's just a nice touch, and it makes even that tight space below the stairs more functional. And here's the finished product. So the width, the height, the comfort of the stairs is really nice, and it doesn't sway at all. It doesn't bounce. It feels really solid, and it leads up to almost nothing. But now you can see the stairway will open up into the bedroom suite with a passageway into the rest of the house. And you can see here just how nice it is. We're completely surrounded by woods, and we're just really looking forward to living here once we get here. But that's where I'm at. Thanks a lot, and see you next time.